Maybe you know someone with a really magnetic personality. I'm gonna bet that their magnetism is nothing compared to some bacteria I know. I'm not trying to insult anybody. These bacteria literally have built-in compasses, known as magnetotactic bacteria. They track the Earth's magnetic field to find the perfect spot in their watery homes. And they've recently caught the attention of a lot of researchers because the tiny magnets they produce might be the next big thing in how we treat diseases and store data. To build their mini compasses, the bacteria take in iron from their surroundings and transport it to special compartments called magnetosomes. Inside each compartment grows a small, near-perfect crystal of magnetite, a type of iron oxide. And as you've probably guessed from the name, magnetite is magnetic with north and south poles. It is, in fact, the most strongly magnetic natural mineral we know of. And each tiny crystal is also a nanomagnet, just a few billionths of a meter in size. But since they're so tiny, individual nanomagnets are too weak to be useful to the bacteria. They just don't respond well to Earth's magnetic field. So the microbes chain up the crystals, combining them into one long, strong magnet. That's what acts as a compass needle, detecting the Earth's field and rotating accordingly. The magnets are so effective that the bacteria get locked into alignment with the Earth's magnetic field, even when they're dead. But what's in it for the bacteria? Well, we know some animals use magnetism to navigate during long migrations, but these bacteria use theirs to stay in their comfort zone. The bacteria live in lakes and oceans all over the Earth, but only at depths where the oxygen concentration is just right. The water's surface has too much oxygen, but at the very bottom there's too little, and bacteria are a little fussy about that kind of thing. Without eyes, or a brain, to help them navigate, they follow the Earth's magnetic field through the water to reach the right depth. Earth's magnetic field comes from deep inside the planet. It radiates out into space and back in through the other hemisphere. Magnetotactic bacteria use their crystal compasses to align themselves up with the Earth's magnetic field. Then they just follow the lines of the magnetic field like a shortcut to the right depth. It beats wandering around in random directions. This simplifies their 3D surroundings into a single axis of movement and a set of basic rules. If there isn't enough oxygen, they know to follow the magnetic field towards the surface where there's more, and if there's too much, just go in the opposite direction. It's a shortcut that lets them quickly get back to their semi-oxygenated happy place. Now, when scientists discover awesome things like this, their next thought is generally, how can we use this? Well, it's still in the early stages, but nanomagnets from bacteria may one day be showing up in your pills and even your computer. Nanomagnets are small, bind readily to other substances, and can be easily retrieved from a mix of other particles. That could make them incredibly useful for medical technology. In a SciShow episode from 2014, we talked about how nanomagnets might soon be used to treat infected blood by delivering drugs to targeted parts of the body, speeding up treatment and reducing side effects. And in computer science, magnets have long been a feature of data storage devices like hard drives and bank cards. Arrays of magnets on a nanoscale could fuel the next stage of humanity's race to pack more data into smaller spaces. So obviously, nanomagnets are great. But why get bacteria involved? Frankly, because they're just better at making them than we are. Nanomagnets made chemically in the lab tend to be a mess of all shapes and sizes. Magnetotactic bacteria, on the other hand, craft their nanomagnets to precisely the same specs every time. If we could learn how, for example, one group of bacteria always makes octahedral crystals, while another type only makes bullet-shaped ones, that could help us figure out how to make nanomagnets in whatever shapes we want. With nanomagnets turning out to be useful in all kinds of new ways, we would do well to learn what we can from those magnetotactic little dudes. Thanks for watching this episode of SciShow, brought to you by our patrons on Patreon. If you want to help support the show, just go to patreon.com/scishow, and don't forget to go to youtube.com/scishow and subscribe.